Good evening, everyone.
Good evening, sir.
So, is there anyone whose exams have started?
Sir?
Good evening, sir.
Good evening. Is there anyone whose exams have started?
Yes, sir.
Good evening, sir.
21st of September, sir. First exam is only science.
Okay, first exam is science. So, hopefully, I think we have completed all the topics.
Yes, sir.
Yes, we have completed all the topics from science.
Yes, sir.
Sir, can we go to Pearson, sir?
Tell
No,
the
there are
index.
like any important
What?
topics, sir. Like important questions.
Okay, you want important questions from which topic?
Sir, from force and pressure, friction, combustion
Okay.
and flame, coal and petroleum.
Okay. Four questions.
I have 6 chapters from science, sir. 4 from physics and chemistry.
Okay, fourth one is from
4 chapters are from physics and chemistry.
what's your first chapter?
Force and
First
pressure.
chapter. What's the first chapter? Force and pressure. Okay. So your first chapter is force and pressure. I think we had done today. We'll do a little bit more in that. In the last class, I added with the friction, right? So in friction,
sir.
we did a lot of things. Today we'll
Yes,
do
sir.
some more parts in, like today we are going to do about fluid friction and how methods of reducing friction, methods of increasing friction.
Okay, sir.
Okay. So I request everyone to be active during the classes to answer the questions. Okay. Be active. The more you answer, the more you learn. Always know one thing, more studies means more doubt, no study means no doubt. So if you don't have any doubts, then you are not studying. Got it? So let me share the screen now. Force and pressure. So
Sir, your voice is low, sir.
okay, it isn't low. I think now it's okay.
Yes, sir.
So for force and pressure, we have to look methods of increasing friction and methods of decreasing friction. Also today in detail, we'll be doing about the rolling friction. So in the last class, our classes were mainly based on the sliding friction. Okay. Today we'll see what is rolling friction. So rolling friction is the friction between two surfaces when a wheel rolls on another surface. So that we call as the rolling friction. Now the causes of the rolling friction, they are not the same as what as we have discussed. The rolling friction has some different criteria. The cause of rolling friction, see the causes of rolling friction. Of course, the criteria, whatever we had seen before, they are also applicable. Okay, but there are other causes also for rolling friction. So what are the other causes of rolling friction? The very first thing is that flattening of tires or flattening of the roller. Flattening of roller. The second one is creation of a hump. So see how does creation of a hump work? See, such things, they are not mentioned in NCERT. They are something extra being added up. Okay. In NCERT, you are just given one line that rolling friction is less than the sliding friction. Okay. Okay. Also remember that our rolling friction is always less than the sliding friction. Friction is less than sliding friction. So the terms which we studied, like the static friction, kinetic friction, okay, they are applicable here also. Here also we apply those terms. We studied about the limiting friction, sliding friction, uh, kinetic friction. So limiting friction and kinetic friction, they are applicable even for the rolling friction also.
Sir, in between static friction and rolling friction, static is greater, sir.
See, there will be static friction for rolling also. Rolling is a type of motion. Okay. So whenever a rolling action is performed, so there is a static friction as well as the kinetic friction.
Okay, sir.
Okay. So it's like this. We are considering like in this way. For the sliding friction, we had studied static and kinetic. Now we are studying rolling, and for rolling also you have static and kinetic. That means for this also you have the limiting friction and the kinetic friction. So when the object is rolling, it's moving, then it is kinetic friction. And when it is just about to move, when it's not moving but it is about to move, then the force of friction is the static friction, which is the same as the limiting and static friction. So the similar things which we studied earlier. Got it? So this is the rolling friction. Now, how does rolling friction work? Let's see with an example how a roller works. So here we have a surface, and suppose on this surface I try to put a ruler and then see what happens. So let's take up a ruler. Okay. So see, when I put a ruler like this, so one thing that happens is that a hump is created. A hump is created means the surface, it gets depressed over here, where at the point of contact the surface gets depressed, and in front of it you have a creation of hump, something like this. You will have a hump like this. That means a part of the material will be collected in the front as a hump. So every time we can assume that this roller is trying to ride on this hump, and this hump keeps on shifting in the forward direction. Okay. So this is the cause of the rolling friction. The another thing that works here is the flattening of the tires. The tires become flat. A little bit of tires, a portion of the tire becomes flat. So if you observe any vehicle, so for any vehicle, the tires, they become a little bit flat. At the point of contact, instead of being exactly circular, they become a little bit flat over here. So
Sir,
something
but
like
I didn't see a hump in like I didn't see the hump anywhere, sir. But I saw the tire being flattened at the point of contacting.
okay. So hump you may not be able to observe on a metal road. Okay, but on a sandy soil you will be able to observe it. Is this correct? If the soil is sandy, or if it's a loose soil and you put your vehicle over there, so you will be able to observe a hump. But
Yes, sir.
if you are putting your vehicle on road, so you see that there is no hump, but there is still a hump which is not observable by our just eyes. We need some microscopic view over there. If you observe that with a microscope, you will be able to observe the hump.
Okay, sir. Like
Okay?
it is microscopic. I didn't.
Yeah.
Okay, okay. Huh.
So on the metal surface, in the same way, like you said that yes, sir, I observed the flattening of the tires. Now you'll say, sir, what about the railway tracks? Is there still the flattening of the those railway wheels?
No, sir.
I don't think so, but it can be in a microscopic level, sir. I don't know.
Yes, there is a flattening. Got it? But the flattening over there is very less. Got it? Understood this?
Sir.
Okay. So this is the rolling friction. Now, rolling friction is always less than sliding friction. So consider here, I gave you a box to move from one place to another. So here I provide you a box. Okay. So I give you this box and I tell you that you have to move this box from one place to another. So this box is lying here on the surface and suppose you have to move it. So how can you move if the box is heavy?
We have to push it with a
Yeah.
pressure.
So one method is that we push it, right? This is one
Yes,
of the
sir.
method. We apply some force over here to push it and this block would move.
Yes, sir.
Okay. So here I am applying some force F to push it. Now there is another way which I can try out. Again the same surface. Okay. And again the same block. So let's say I have the same block. And but now I just lift this block a little bit and I put rollers underneath it. So if I put rollers over here, small rollers.
We have to apply less pressure. We have to apply less pressure to push,
Yes.
like to move
So
it forward.
again we have to move it. So which method is easier one?
Second one, sir.
Second one, right? So for the first one, here you are applying some amount of force F and here also you are some amount of force. So let this be F1, let this be F2. So which force will be greater?
F1, sir.
F1.
Yeah, F1 will be greater. So here, which friction is greater?
Sliding friction.
Static friction.
Yes. So by
Static
this,
friction means F1, sir.
yes. So here we consider, or here by this activity we come to know that sliding friction is greater than the rolling friction. Got it?
Sir,
Yes.
why hump is important, sir?
Hump is important.
Yes, sir. Why is hump important to move?
Hump is not important to move, but hump is created, which is the cause of friction, which is the cause of rolling friction. The hump that is created, that is the cause of rolling friction.
Okay, sir. Oh, yeah.
Got it?
But how it forms the hump, sir?
By due to its weight.
Oh,
Due
okay,
to
sir.
due to the weight, the roller is displaced a little bit into the ground. As a result, the material of the ground, they are displaced to the side. So as a result, a hump is created. Got
Sir,
it?
understood. Yeah.
Okay. So suppose if you have to move a heavy almirah in your home, you are not able to lift it. So what you can do?
I can push it on the wheels, sir.
Yes, sir.
If it has a wheels, then good. If it doesn't have wheels, so you can push it by keeping some rollers underneath it.
Yes, sir.
Sir, or we can push it with a heavy force with the sliding friction. Like that will be the sliding
Yeah.
friction.
Okay, so see, I think I can find some of the images by which we can show. Okay, so see. Okay. So see, either you can put these rollers or you just lift it a little bit, put the rollers below it, and you will be able to move it.
But even for washing machines, we use like this type of tool.
Yeah, so in the washing machine, they already have wheels, so you can move it easily. Had there not been wheels, so it would have been quite difficult for you to move those machines.
Like sofas, chairs, heavy
Yeah,
ones.
sofa, chair, whatever is there, so that can be moved easily with the help of the wheels.
Sir,
Got it?
I actually have one of the rollers, sir. I have it right now.
You have one of the rollers?
Yes, sir. For
Which
moving
one?
the gas cylinders, sir.
Okay, okay. This one, I think this one you must be having.
Sir, I have a doubt.
Yes.
Sir, here by this we reduce the friction, sir.
Uh, Pardon again.
Sir, means now you are telling that if we keep the wheels, it will move easily. Now we are here we are reducing the friction.
Yeah, we are reducing the friction.
Okay, sir.
Okay. Now, so wherever we have sliding friction, we try to convert it to rolling friction. Okay. Can you think of a bus with flat wheels? Will it be easy for the bus to move?
No, sir.
No.
Oh, sir.
Why? What causes can be there?
Sir, like if the wheels are flat, it cannot move because of the static friction.
Hmm.
So rolling friction, not it just rolls on the other.
Sir,
Yes.
the road does not means provide that much friction to the bus.
The road does not provide.
And too much of friction to
See, there will be a lot. There will be a lot of friction. Okay. So there will be a lot of friction, and hence a lot of energy will be used in pushing the pushing the bus on the road. Okay. But the same thing is easy somewhere else. It's somewhere easy to use sliding friction instead of rolling friction. Can you think of places where it's better to use the sliding friction instead of rolling friction? Can anyone think of situations where we use sliding instead of rolling?
sir,
Sir, sir,
Yes.
sir, skating means
Yeah,
skaters.
skating on ice.
Yes, sir.
Skating on ice. So when you are skating on ice, okay. So for skating on ice, we prefer sliding instead of rolling. Can you think why?
Sir, because
Sir,
if we,
because it will be slippery if we use rollers.
We must
Yeah,
repair.
rolling is not possible.
Yes,
With
sir.
very small amount of friction, rolling is not possible. Okay, so it's not possible for the wheels to roll on ice. So that is why over there we use sliding friction instead of rolling friction. Otherwise, at most of the places we try to convert our sliding friction into rolling friction.
Sir.
Okay, so let's see where all we convert our sliding friction to rolling friction. One of the examples of this is ball bearings. Okay, so
sir,
we use
even
this.
lubricating oil.
Yeah, we use ball bearings or lubricating oils. So see, in these ball bearings, you have these balls placed between two rings. So a ball bearing is a set of two rings fitted with balls, or it is a set of balls fitted in two rings, concentric rings. Okay, so whenever one of out of the two rings, one of the rings is stationary and one of the rings is moving. So generally the inner ring is stationary and the outer ring moves. So if the outer ring moves, so obviously it will slide over these rings. Okay, so you have provided here in between, the rollers are provided, or rings balls are provided, which will roll over and hence reducing the amount of friction. Got it? So these ball bearings, they are very important in mechanics. Let's say ball bearings in fans.
sir, sir,
Sir,
Yes. Yes.
sir, sir, between these there is no friction, no, sir. There is a gap.
Where there is a gap.
in the ball bearing, the outside and the inner layer has a gap, sir.
Yeah, there is a gap, and that gap is filled with the ball bearings.
So in the gap, friction is not there, no sir. It's just air.
Yeah.
So why use of ball bearings, sir?
See, when there is that gap is maintained due to the ball bearings only.
Okay,
Okay.
sir. Okay.
Okay.
Sir,
And
and
in
one more thing, there is gap between the balls also, right, sir? The
yeah,
balls would stay closer, then there would also be rough surfacing or
yeah,
friction would have occur there also, right?
yes, yes. Okay, see here you see in the way these ball bearings have been placed in a fan. Okay, so as we observe that the outer portion of this fan, it keeps on rotating, whereas the inner part of the fan, which is fixed with this axle, is not rotating. Got it?
Yes, sir.
So the inner portion is fixed and outer portion is rotating. This is made possible with the help of the ball bearings.
Sir, do ball bearings make the like do ball bearings make the rolling easy, sir?
Yeah, ball bearings, they made the rolling easy.
Sir, today I got a question like, what are ball bearings? What is its use?
Okay, so I just told the definition orally. Now I'm writing it, you and all of you must write this definition. Okay, because what you write in the exam, that will carry marks. Okay, so let's write what are ball bearings. You see, I told the definition. It is a set of metal balls fitted in concentric rings. It reduces friction between the rings by converting it to rolling friction. Got it. So this is your complete answer. What are ball bearings and what does it do? Okay. All of you just make a note of it. I'm coming in. Just give me one. It's okay. Yeah. Can you continue again? Okay. Any other doubt?
No, sir.
No, sir.
So see, I'll also show you the ball bearings used in cycles. Okay, and then we'll see the methods for. We'll also see the methods for decreasing friction. Okay, so one more, just see the ball bearings in cycle. See, are there ball bearings present in cycle?
Yes, sir.
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 So
Yes,
here
sir.
you see the ball bearings. These are present here to facilitate the motion between the axle and the wheel. And you can see the space between them is filled with grease or oil to reduce the friction.
Sir,
Sir,
sometimes
ball bearings themselves are used to reduce friction, and then why are we using again lubricants?
Yeah, it is required because see, if you are using just ball bearings, okay, so there will the friction will be reduced, but it will not be reduced to a very less extent. We want your vehicle to be moving with very small amount of force. We want to reduce friction as much as we can.
sir, sometimes when we are pedaling faster, the balls will also fall out, sir.
What happened?
Sometimes when we pedal more fast, the balls will also fall out.
Yeah, those are the things that may happen in machinery. Those are the cracks and other things they can happen in machinery. Okay, but this is where, see, where we use these ball bearings even in cycles. In other vehicles we use this ball bearing. See, here we are using these ball bearings. Got it?
Sir,
So
I
I
have a
think
doubt,
Now,
sir.
nowadays, these ball bearings, the cycles are not coming.
the ball bearings in cycles,
Are not coming much.
okay, they generally don't come out. They are fitted in uh, they are fitted in a quite good way. So they are not fitted to come out, but maybe some chances are there that there may be accidents, there may be some things that yes, it can come out only when if it becomes loose or anything else that can happen. Okay, otherwise it's very rare that they come out. The chances are very less. Yes, so I think everyone is
If it
clear
will
with the ball
about
Sir,
bearing.
sir, I have a doubt, sir.
Yes, what's doubt?
Sir, why won't we use metal tires in vehicles, sir?
Yes. Uh, Very good question is that why don't we use metal tires? So what do you think would be possible? First of all, to reduce the jerk. Okay, the air pressure that is there, it absorbs a lot of shock from the wheels. If you have metal wheels, so the jerks may not be absorbed and they may lead to deformations of those metal wheels. Okay, as for that, you should have a uh, for those wheels. If you have metal wheels, then the road should be very smooth. Okay, and also the turning effect when the vehicle turns out. So when the vehicle turns out, there should be a grip between the road and the vehicle. Okay, so it's not only that you have to reduce friction. Over there, the friction will be so small that you will not be able to turn. It won't be possible to make you a turn uh, on a track.
Sir, what if we cover it with a rubber surface, sir? Like
Yeah. So
we don't have to push the air. Like we don't have
yeah.
to always.
So that's what you are driving your vehicle without any air or flat tires.
Yes, sir.
Mhm. Okay.
We don't need to fill the air in the tire, no, sir.
That is hello. That is correct. Yeah.
Don't need to
What
fill the
happened?
air in the. We don't need to feel the air in the wheel, no, sir. That's why. If we have a rubber covering inside the metal surface.
Yeah, you can have a rubber covering. You
But
can
without
see, you can have a wheel made something like this also. See, you those kids bicycles, they come like that only. Okay, in the kids bicycle you have the same thing. You have a metal ring, and that metal ring is covered with rubber. It's something like this. So the ring being covered with a rubber over it. The complete space, this all is rubber.
Yes.
Everything here is rubber. This whole thing is rubber. There is no air. So generally the kids cycles, they come like this only.
that because kids mostly ride on a smooth surface, sir.
Yeah,
Because kids usually ride on a smooth surface.
yeah. Kids usually ride on a smooth surface.
That's why they keep only rubber surface. Okay. But
Yes.
but if we are going to ride on a rough surface, then we need air, sir, to absorb the jerks.
There are different reasons. Adding rubber will increase the weight of the vehicle. Okay. If you add a rubber to the wheels, it will increase its weight. Okay. Any other doubt? Apart from weight, there are other considerations also. However, scientists are trying to make the tires without air. Okay, like you can see, they are developed with different material, and in such a way they are designed that the gap between the tires will be filled only with the natural air. Okay, it doesn't need any specific pressure air in there. Got it?
Sir, but we can use metal instead.
Okay,
Interested metal.
okay, what do you think? Do you think that if we can we use a vehicle with tires outside the space, outside into the space?
No, sir.
No, sir.
No,
No.
sir.
Over there, the pressure will have different rules. Okay.
Yes,
Okay.
sir.
Anyways, student. Bye, all of you. We'll see you again in next class.
Bye, sir.
Bye.
Bye, sir.
Bye, sir.
Bye,
Thank
sir. Thank you, sir.